Hi, my name is Caddy Heron, and I just moved from Africa. I just started at this high school, and I met some real bitches named the Plastics on my first day.
My milkshake brings all the boys to the yard, and they're like, it's better than yours, damn right, better than yours.
This is Gretchen Wieners. She thinks she's a big deal because her dad invented the fundamental theorem of calculus. That's why her hair is so big. It's full of derivative cheat sheets. This is Karen Smith. She's so dumb she thought Euler method was something you need to change in your car. And evil takes form in Regina George. How do I begin to describe Regina George?
Regina George is flawless. I hear she does YouTube videos with Cindy.
Oh, hey, Regina, I have something to talk to you about.
Okay, make it quick. I have a date with Aaron later.
Hours later.
And these are my real friends, Janice and Damien. Right now, we're plotting to get Regina back for stealing my man.
What are we gonna do about that scum-sucking rodent, Regina George?
Hey, Katie, are these granola bars low fat?
No. Those are Caltine bars. My mom used to give them to the kids in Africa to make them gain weight.
That's perfect.
A few moments later.
Hey, Regina, I've been looking for you. I wanted to give you these Caltine bars. We used to give them to the kids in Africa to lose weight.
Oh, that's perfect. I really want to lose 3 pounds.
Oh, no, you don't.
Oh my god, stop.
2 hours later.
Hey Regina, I was just calling to let you know that I think you're looking really fat these days.
Boo, you whore. I don't know why I'm getting so much weight.
I think that if your cells have a 20 to 30% chance of dividing, you're gonna get fatter and Aaron's gonna break up with you.
Oh no, I have to approximate how many fat cells I'm gonna gain then.
Oh, I can figure that out for you. I got an A in US history.
To calculate the approximate total number of Regina's fat cells with a 20% to 30% chance of dividing during the next hour, we first have to find the antiderivative of the function nx equals the square root of 5x plus 1. We then find the integral of this equation ranging from 30 to 20. From this equation, we find the approximate number of Regina's fat cells that have a 20% to 30% chance of dividing during the next hour to equal 560.3, which we can round to 560 fat cells.
Karen, you're so stupid.
2 hours later.
I don't know why this dress isn't fitting me anymore.
I don't know, Regina, you have been putting on some pounds. I think if you have more than a 60% chance of your cells dividing, you're going to get even fatter and you won't be able to fit into your dress for your date tonight.
We need to figure out the approximate number of cells that have less than a 60% chance of dividing the next hour then.
I think I, the daughter of the man who invented the fundamental theorem of calculus, can help you figure that out.
In order to approximate the total number of cells that have less than a 60% chance of dividing during the next hour, we take the function given, nx equals the square root of 5x plus 1, and find the antiderivative. We can then set the integral ranging 0 to 60 to find the number of cells, which is 3,480.73. This fraction of cells must be rounded to the nearest whole number. 3,481 is the approximate number of cells that Regina will gain that have less than a 60% chance of dividing. So maybe she will be able to fit into that dress. How fetch.
Meanwhile.
I called y'all here for this emergency mathlete meeting. I called y'all here today because I gave Regina Caltine bars, which is making her cells divide, which is making her gain weight. No, guys, this is serious. So I called y'all here today because I'm worried that if Regina keeps eating these Caltine bars, she's going to get so fat, it's going to totally ruin her life.
What do you care? She stole your boyfriend.
Yeah, but I'm a better person than her, so that's why I care. So these Caltine bars, the more Regina eats, the higher percent chance she has of her cells dividing, which will make her fat. I drew this graph to model this relationship.
The area under the curve is the cumulative rate at which the probability of cells undergoing division actually divide, because the area of the graph is the integral of the given function.
So if you look at the area under this graph, or the integral, you can graph the relationship between percent probability of the cells dividing and the cumulative number of cells, which I graphed here. The integral, or the initial function, tells us the cumulative rate at which the probability of cells undergoing cell division actually divide. This means that the approximate total number of cells within a particular percentage for the chance of dividing during the next hour is the cumulative rate. This graph shows the exponential nature of the original function, thus concluding that the cumulative rate at which the probability of cells increases rapidly with small increases in the percent chance the cells will divide.
3:28 a.m.
Oh no! The limit does not exist! There's no equilibrium. Oh my god, Regina, you need to stop eating those calcium bars. You're gonna get so fat, you're gonna pop. Now,
You're the one who gave them to me, you homeschooled jungle freak.
I know, I'm so sorry.
Oh my god. You know what people say about you? They say that you're a less smart calculus student than me. Yeah, so take that and shove it up your...
And that's how Regina George died. Just kidding, but she did pop her butt.
Marlena doesn't even go here.
Yo, all you sucker MCs ain't got nothing on me. From my grades to my lines, you can't touch Kevin G. I'm a mathlete, so nerd isn't bird, but forget what you heard. I'm like James Bond III, shaking, not stirred. I'm Kevin the Poor. The G is silent when I sneak in your door. I make love to your woman on the bathroom floor. I don't play it like Shaggy. You'll know it was me, cause the next time you see her, she'll be like, oh, Kevin G.
Thank you, Kevin. That's enough.
Happy holidays, everybody.